Hi everyone. So first of all, thank you so much in order to assist you into the webinar. Welcome to the Experts Corner. The idea of this webinar is try to answer your questions. So again, thank you so much for these questions. We received a lot of questions, so we need to filter some of them, and we try to answer all of them because there are similar topics. So could be possible that some of these questions are related that some of you assist in that webinar, and other questions, if not answers, just please use in the chat, and then I am going to ask to our CTO and CEO to answer in live. So, and then I'm going to pass to the webinar in charge the webinar to Cristian de Santos and Ignacia Liguer. So just thank you so much again for your assistance.
So thank you, Carlos, for the introduction, and again, thank to all of you guys for being here today with us. For us, it's really a good opportunity to share with you some of the answers of your questions, and that's showing that what we are doing is on the right path because there are really interest in how to improve geotechnics. So we are really happy to be here today. Just for the benefit of some of you guys, I will just give you some short introduction of our solution. As you can see here on the screen, Darwin looks like a tool with many different tools where you can analyze historical data from geotechnical reports, how you can create ground models from laboratory tests, in situ tests, how you can analyze data coming from tunnel boring machines. So many things can be done in Darwin. If you can see all the specifications, so Carlos, if you can pass, next one. So Darwin can be used to multiple things. First thing, Darwin can be used as a public ground information system, basically as an aggregator of public information that it's already available in other systems, but now it's open and accessible in Darwin, especially to plan your initial geotechnical campaigns. Of course, many of this public information, but also your own information from your corporations, many times it's in analog format. So also Darwin provides you a functionality to digitalize this information. So coming from an old geotechnical report that have been scanned to fully digital information. Then, of course, what to do with this digital information? We can create full ground models. To do that, we have different functionalities in Darwin as our private ground investigation data management tool, where we can analyze laboratory tests, in situ tests, correlate different boreholes from different sources, extract and calculate geotechnical parameters based on all this information. And then we can create different cross-sections to actually start creating our initial digital ground models. Then, as many of you know, Darwin is a tool to calculate hundreds and thousands numerical models on the cloud, trying to combine models with monitoring data to calibrate those models to make better predictions. So, of course, Darwin is a high-performance cloud computing for sensitivity and back analysis. As you can see, once you have data, of course, this data can be visualized as an instrumentation and monitoring tool in Darwin. And finally, one of the newest functionalities that we add in our system is our tunnel boring machine data management tool that helps us to analyze in real time all the data coming from the sensors installed in a tunnel boring machine to predict the advance rate of the machines, to be able to recommend to the pilot what parameters the pilot can adjust to improve the performance of the excavation, as well as detecting geotechnical anomalies. And most important, all this information can be centralized and stored for future projects. Basically, what we are doing is creating a library of different predictive model for different machines in different ground conditions. So as you can see, Darwin is almost covering the full life cycle of a geotechnical projects. So having said that, again, thank you for all your questions, and now Carlos will moderate this session of Q&As. So Carlos. Carlos, you are mute.
Sorry, I'm going to start for the first question. In that case, this question is, what inspired you to establish Salt Geomechanics, and how did your backgrounds influence the company's direction?
Hello, good morning and also good afternoon for some of you that are connecting from other parts of the world. Me and Christian started Salt Geomechanics in 2016. We were former researchers at UPC in Barcelona. We were involved in PhD's program in soil and rock mechanics, respectively. And what we saw is that the research that we were involved in had a high potential to disrupt the geotechnical engineering design industry and more broadly construction and mining industries. And even though all the academics in our university were really prestigious, we were more interested in applying such technologies within the industry. So following the advice of business angels and people from the Barcelona startup ecosystem, so we decided to take the leap and incorporate Salt Geomechanics. And thanks to our relationships with the professors and how they had been and they are still involved in consulting projects with big and large infrastructure projects in Spain, so we had the change to start Salt Geomechanics and from the get-go be involved in geotechnical engineering projects, both in Spain but rapidly also internationally.
Yeah, actually, if we should need to define why the reason, I think was this willingness to really bridge the gap between academia and the industry. At the end, we didn't wanted our research to be storage in a place, in a PhD thesis, in technical papers. We really wanted to impact the industry. And I think, and that was part of the reason or what inspired us to actually establish the company many years ago, though.
Okay, thank you, Christian Ignacy. The second question is, how has external investment influenced the growth and direction of Salt Geomechanics, and how do you ensure alignment between your long-term vision and the expectations of your investors?
That's not an easy one. You need to think first that Ignacy and myself, as Ignacy said, we were researchers. We were geotechnical engineers. We didn't know about anything related to investment, manage a business. So it was something new for us. So how you need to deal with investors? At the end of the day, what we are doing at Salt is doing innovation. And to do innovation, you need funding or you need resources that you need to get to actually have these sources to keep developing new technology that sometimes it's not ready yet for the market. In our case, we were looking for investment after going through different accelerator programs, helping us to understand what is an investment, how you can work with investors. And basically what we were doing was showing to different investors, initially some public institutions, but then some big agents in the construction industry, like the Mexican cement company Cemex. Then at some point we were talking with the British consultant firm Mott MacDonald, and most recently with the Spanish contractor Acciona. So what they saw on us was a good team, a good technology, and a vision that they were sharing with us. So that's really important to share this vision, especially for the long term. And then they support you. And of course, the relationship not always it's easy, because at the end of the day, you need to realize that your company is an independent company to those companies that are investing in you, and each company have a different agenda. And sometimes this agenda, especially the long-term agenda, it's different. Of course, there are also other type of investors. It's not a strategic investor, a financial investor, so the long-term vision can be different. But the important thing is to share the values and have a common goal. Do you don't think that, Ignacy?
Yeah, our growth has mostly been related in terms of investment to corporate venturing, and those corporates and this venturing process aligns or has affected us in different stages of our growth. Cemex Ventures invested early on at the end of 2017, and it helped us with our go-to-market and also puts us in contact with a lot of contractors in the Latin America region. Then later on, just right after COVID, we received the support of Mott MacDonald. Mott MacDonald is a large British engineering firm that had been involved implementing the OM in the past in different projects in the UK, and actually really helped us to shape our high-performance real-time back analysis tool and how to implement that in real projects. We implemented that in 3 contracts of high-speed 2 with them. And then more recently, Acciona is helping us to shape our tools in the field of underground excavations, like basically mechanized tunneling, but also conventional tunneling with drill and blast for construction and underground mining.
Okay, thank you, Ignacio and Christian. The third question is, what are the barriers to the implementing designs updates during the construction, and how do we fix this?
Well, that's a real challenge, and with Ignacy and our team, and especially after talking with many potential customers, that's the biggest challenge, is how you actually implement a good technology in an environment like the construction sector, which is a quite risk-adverse agent. So here, that's a key. And I think that the biggest barrier are the contracts, because at the end, what Darwin and our solution is offering, it's a tool that helps to implement the observational method, where you start with a conservative design based on the geotechnical information that you have in the early stages, and then based on the more information that you are gathering during construction from sensors, from more geotechnical campaigns, you are enhancing and improving your design. But that can be done if all this process and all this method of the observational method, it's agreed with all the different shareholders of a project, asset owner, contractor, and designer from the beginning. If not, it's almost impossible to do that. We have multiple examples where we prove that our technology was showing that ground conditions were better, that we could reduce the material consumption because we could reduce the number of anchors, temporary props. But the contractor was saying, if I don't install those elements, my client is not going to pay me for those elements, and I really have a good price on those structural elements, so I want to actually put those elements. And that's limiting the possibility to improve engineering and construction. So having a contract like design and build that is creating a strong relationship between the contractor, the designer, and the asset owner, and promoting that some of those improvements are giving something in return to the contractor and the designer, it's actually helping to minimize those barriers of the implementation. I think that in one word or one phrase, the biggest barrier are the contracts of the projects that are not allowing or sharing the benefits of implementing this kind of progressive modification design. Carlos, you are on mute.
Sorry again. So thank you, Christian. And the next question is, are you planning to make this sensitivity and debug analysis functionalities compatible with other finite element method softwares beyond Plaxis?
Yes, as you know, Darwin accepts as input finite element models from the Plaxis suite. We started long time ago with Plaxis version 9, and then we incorporate like the recent versions, like from 2016 to last update of 2024. We're waiting for the release of Plaxis 2025. That still is gonna take, I guess, few time. We are people or well, basically engineers that we work with and companies, customers of us also use finite element or finite differences suites from Rock Science and also from Itasca, basically Flag. We are not compatible with those yet, but we have plans that in the future we're thinking of not incorporating them directly, but just offer Darwin as a system or as a framework that it's where the companies will be able to deploy our real-time back analysis and sensitivity high performance cloud computing with their own machines or with their cloud provider of their own choice with a standard framework.
Okay, thank you, Ignacy. I think so. Previous to pass to the next question, there is a new question of Jing Chen that asks about if it's possible to give or to provide more details about the ground investigation data management function of Darwin.
Well, that's a functionality and that's related to other questions we've had. Darwin ground investigation data management functionality has been intensively developed in the for the last 1.5 years, and that was a need that we only had previously. Our core technology of sensitivity, more real-time back analysis, was limiting the use of Darwin during the execution or construction stage of the project. Then we found the need to move and develop tools for the engineers to apply during planning and design. We started with sensitivity analysis, and then actually we first implemented the public ground investigation information system that aggregates all the public ground data available, both in analog format and in digital format. And then is when we realized that it's of great value for the project engineer to start the geotechnical design workflow having digital ground information data. So it's then we were in contact with digital formats of ground data exchange as the AGS, and then we decided to implement this part of the software to input to the system all your ground investigation data, such as borehole logs, trial pit logs, all the in-situ testing, such as standard penetration test data, CPT, also dynamic dynamic penetration tests, but also all the laboratory test data, and then be able to, in a project, be able to define units based on grouping all this data, having all this data available, and then finally, from those units, being able to create a ground model and only also calculate geotechnical parameters from all this data, taking into account the new developments of the Eurocode. Basically, we're compatible. We started being compatible with the first generation of the Eurocode to calculate geotechnical parameters, and now we're using the second generation. We're also really excited to announce that we are collaborating with Mont McDonald's engineers to be able to fine-tune the functionalities of the ground investigation management tool.
Okay, so thank you, Ignacy. There is another question from Makaran Karet. Can you import ground investigation data from other softwares such as GINT or others?
Yeah, we are aware that most of the softwares in the market, they have the functionality of export data using AGS. The AGS, it's been a standard in the British world, for the British and in the Anglo-Saxon world for many years. I think it become really strong with the Crossrail project, and it's been improving since then. Most of the commercial software have the ability to use this format as a format for exchange ground data. And Darwin, the part of the ground investigation in Darwin, is fully compatible with the AGS format. And actually, I can tell that the performance of importing data with AGS is quite good.
Carlos, you're on mute.
Sorry, automatic way. So the next question, I don't know if someone of you have any additional questions. If not, I'm going to pass to the rest of the questions. The fourth question is, are you planning to make the sensitivity and back analysis functional? What is the price and its subscription based?
Well, here is not a direct answer. As you could see, Darwin can do multiple things. So basically how we are commercializing Darwin are in two different formats. There is a monthly subscription fee, basically to access to all the different functionalities where you can upload information, storage information, and visualize information. That's covering our ground information system, our capability of connecting numerical models with monitoring data, as well as visualizing and acquiring automatically all the monitoring data that you have in your project. So that's a subscription. And then we are charging based on usage. That's basically for running your sensitivity and back analysis. You have to have into account that every time that you launch a parametrical analysis, calculating hundreds of Plaxis on the cloud, as well as running thousands of different Plaxis models on the cloud for a back analysis, we are using by default 200 virtual machines with 200 Plaxis license. So that's charged by the hours of consuming computational resources. Then the other part where we are using high performance computing is while digitalizing analog PDF from geotechnical reports. So that's based on the number of pages that we are digitalizing. So again, the only thing that you need is your subscription to be activated. You will pay a monthly fee that can go from a few hundred euros per month to a few thousand euros, depending on the volume of data that you need to manage. And then you will pay for computational resources. For the tunnel boring machine, there is a separate subscription because the volume of data and the number of sensors are completely different from a conventional project. And what it's true that for the tunnel boring machine, the level of the setup is quite higher than the normal project. So here there is a big part of the cost associated with the setup and all the customization. Each tunnel boring machine have different sensors, different ways to be operated, so we need to customize the functionalities depending on the needs of the projects. But basically, monthly subscriptions for a few €100 per month, plus computational costs for sensitivity back analysis and digitalization. But any case, if someone have a specific project with some specifications, please do not hesitate to contact us or Carlos, and we can give you a quote for your specific project.
Okay, thank you, Christian. We have an additional question from Makaran Kare. So the question is how the instrumentation and monitoring data is fit into Darwin.
Okay, in Darwin, you can input instrumentation and monitoring data basically in two different ways, either manually or automatically. In terms of manually, so let's say that you have either classic topography surveying, or you have manual, or you have digital data loggers that you read and you bring this data to your office. In such case, we have Excel spreadsheet templates that when you have your project you can download, and then you upload your readings to this Excel spreadsheet, and then you upload them to the system, and then the system knows if that instrument already have those readings. Then the system doesn't insert the readings, but if it sees that in the Excel spreadsheet there's more reading than what they are in the system, like inserts the new readings, and then you can visualize this data in Darwin platform. In terms of automatic monitoring, we're compatible with certain providers, the most common ones, which are World Sensing here in Barcelona, Accio from Singapore. We're also compatible with Sensif in the UK, and then we're also compatible with we have established a direct connection with iTwin IoT from Bentley that incorporates machines from Sensemetrics, and also with shape arrays from Measuran. So we cover a wide spectrum of typical I&M sensors in civil engineering, and we can connect either by FTP. So when you have a project, we create a folder in our FTP server, and then we share with you the URL, the user, and the credentials for that project, and then you introduce those credentials within your system, and we start receiving data automatically that you can see in Darwin. This works very well when you have a frequency of readings of more than, let's say, around 1 hour or more. That's the typical projects where there's 2 or 3 readings per instrument per day. But when the frequency is higher, let's say that there are readings every few minutes and you want to see this real time, then we make the connection through API. So in the setup, we connect to the system, so you can see if it's a system that we are compatible with, you'll see the instruments on that system that the gateway is receiving data. Then you can import this to Darwin, and you start receiving data real time. That's with REST API, and then there's providers that still incorporate more sophisticated ways of transmitting data, such as data streaming. In such case, that will require customization, but we can do that with an enterprise subscription, and we have experience implementing this, so it's gonna be, the setup is gonna take a little longer, but we can also implement that.
Okay, thank you, Ignacy. So I'm going to continue with the next question. How shall integrate the results of different salt investigation methods as CPTs, CPT-DH, SCT?
Yeah, I already covered this a little bit in my preview, so I'll cover this and the next one, which asks also if Salk system is compatible with the DIX file format. Okay, we're working to make Darwin compatible with DIX format. DIX format is a format that's growing its popularity rapidly in US and Canada. It's an XML-based format that we're working. It's at the end, it's all the formats are very similar, because all the in situ and laboratory tests that you can have in ground investigation, they're not that many, and the standard ones used in everyday projects, they're very similar, and there are commons. The good thing is that our data structure can incorporate standard tests from different countries, the ASTM, the British standards, and then German. We haven't worked with Japanese, but our data structure incorporates all these different standard tests, and it's just a matter of mapping from one data format to our data structure. So hopefully we can announce soon, hopefully before the end of the summer, that we are compatible with DIX. And in terms of CPT, SPT, and all dynamic penetration test data, usually SPT data, it's already in the input format, and we read it, and you can visualize the SPT at its depth, and then you can use all this data to calculate soil parameters with the standard formulas available, and also in the ground model functionality, you can see from different boreholes at different depth all the SPTs, and then you can check if for different units there's linear variation with depth is more constant, and so on and so forth. And then with CPTs, the CPT data can be embedded within the AGS or the input file, but also we accept the user to input the CPT data as a formatted data file. So we also are able, we have a tool that the user introduces the data file, the system reads the header and maps each column of the data file with our data structure, even if it's because sometimes these files can also have ground, like geotechnical parameters calculated within the file with different format. We also incorporate, we also have implemented different formulas to calculate soil parameters, and also we run, in case that in the CPT there's not a borehole where you can see the layers and correlate the layers with the CPT penetration and skin friction readings. We also implemented an algorithm to interpret this data, and also does a recommendation of interpreted layers from the CPT data.
Okay, Thank you, Ignacy. So the next question is, do you have any plans to translate your work of offshore geotechnical projects?
So the answer of this question is already you can do it if you want. As you know, at the end, what Darwin is doing in terms of sensitivity and back analysis, which I believe this question is referring, the only requirements that you need to actually use the software and get the results is having a Plaxis model representing your problem. In this case, could be how you are calculating the foundations of a windmill farm. So that's something that you can do. And the other thing that you need if you want to actually calibrate that model, it's data from sensors that you can install there to see the response of the foundation. So yes, you can do, and you can actually use Darwin for offshore projects. There is no limitation. The only requirement is having your model and data if you want to cover sensitivity and back analysis, or if you just want to do a parametrical analysis, which is what we call sensitivity, you create your Plaxis model of the foundation of this kind of offshore structures, and then play with the different geotechnical but also the structural parameters inside your model to see what are the most influential parameters on the response of the model, that at the end are those parameters or those metrics that you are using to define your final design. So yes, you can do that already in Darwin.
Thank you, Christian. So I don't know if you would like to add something, Ignacy? No? Okay. Okay, the next question is, do you have any experience on using Darwin in tailing dam projects?
So this question is also related to the previous one, because it's true that our background was more focused when talking about back analysis in underground projects, because our previous experience, we were lucky enough during our PhD time to be involved in our university working in one of the major high-speed train project that was being built at the time. So we were actually modeling underground structures. But there is no limitation to use the back analysis methodology in different fields. And tailing, it's one of the fields that actually it's been using more intensively Darwin at the moment. Why? Because there are really risky geotechnical structures. The failure of those structures can have a huge impact, not on the project, but on the people surrounding those geotechnical structures. How we are using Darwin in those projects are basically with two different approaches. One is calibrating ground conditions. Permeability is vital for those structures, but also stiffness or some important parameters simulating the complex ground behavior of those geotechnical structures. So basically, we are analyzing water pressure, settlements, as well as CPT data. We are not only calibrating permeability, stiffness, but also some specific parameters or some complex constitutive models that geotechnical engineers are using right now to simulate the behavior of those tailings, like the North-Sun constitutive model. So we are actually calibrating state parameters from the North-Sun constitutive model using CPT data, which is something extremely new. There are some publications that are coming from some clients that are using Darwin in tailing dams projects. So one thing is calibrate the model to analyze stability, but the other path of using Darwin in tailings is understanding the speed of the raising of the tailings. So basically, if you adjust the permeability of your tailing, you can analyze how much time you need to wait to raise again the tailing, and basically how you can increase the operation of your mine.
Okay.
Yeah, I wanted to add that in the case of tailings dams, there's been recently and not that recently failures, and when analyzing mechanical stability, the industry has been using limit equilibrium, but with limit equilibrium you cannot capture certain things that are really important in stability of tailings dams with this the dissipation of excess of pore water pressure due to consolidation after like a growth episode of the tailing dams, and using finite elements and using more sophisticated constitutive models improves the assessment of stability enormously. And also due to also recent failures, tailing dams are heavily instrumented, so I think Darwin is quite the tool in order to be able to combine predictions from finite elements with sophisticated constitutive models with real-time data coming from the tailing itself.
Thank you, Ignacio. Thank you, Christian. So the next question is, what are your plans for expanding Darwin capabilities, particularly in the tunneling sector, and how do you foresee its evolution?
Yeah, here it's actually really exciting what we are doing in the tunneling, both in TBM. In TBM, it's already in a commercial stage, but also in conventional tunneling, especially like in drill and blast tunneling in rock mass conditions. In terms of TBM, we've developed a software that's able to predict the advance rate of a tunnel boring machine, analyzing data from previous excavation, from the previous excavated rings. And we also are able to detect geological anomalies in advance. And we also have the functionality to support the TBM driver improve the excavation. So we are able to tell the driver with our predictive model how much the advance is gonna increase if the driver increases the thrust or increases the screw conveyor speed or the cutting wheel speed. And we also provide the driver with information related to other parameters that changes in those parameters might mean that there are anomalies. There can be anomalies in the way of their excavation, such as the torque or the chamber pressure in case of EPVs. We've already applied this technology. Well, we trialed that technology in a small diameter single shield TBM in rock in Spain, but now we have successfully implemented the software in 2 EPVs that were excavating line 6 in Sao Paulo Metro in Brazil. And we currently have the system in production in a 15-meter diameter EPV in Poland. So that's exciting news in TBM, but also we have an R&D project working in automatic tunnel phase recognition using laser scanner technology from a mobile device. So we're already trialing this solution in a small tunnel here in Barcelona. It's actually like an emergency gallery that goes from one tube of a tunnel to another. I think it's a 3.5 meter diameter. It's a system that's gonna that using the LiDAR sensor in iPhone is gonna scan the tunnel face, and then we're gonna apply two types of algorithms. One analytical algorithm that's gonna analyze the laser scanner, the point cloud, the 3D point cloud, and it's gonna recognize discontinuities like fractures, and also we're gonna have image recognition that's gonna identify those fractures and then calculate automatically like the rock mass rating or Q-Barton geomechanical indexes.
Okay, thank you, Ignacy. So I'm going to pass to the next question. Have you started using AI in geotechnical engineering? Do you use AI to analyze site investigation data? Tell me your experience, please.
So actually the answer is yes, we are using artificial intelligence in different ways. One of the ways, and the first one that we were using, was for back analysis. We are actually using genetic algorithms to calibrate those Plaxis models with monitoring data. At the end of the day, the back analysis, you need to define what parameters you want to calibrate. You need to define a specific potential range of values of each parameter that you want to adjust. And of course, you could try to calculate the whole bunch of combinations that can you get by doing this combination. Of course, there is no such a computer to be able to do that, so you need to use a clever algorithm to calculate some of them and get the best possible combinations that are matching what you are measuring. So in this case, we are using artificial intelligence to find those combination of parameters. Then the newest artificial intelligence that we are using in Darwin, it's basically to digitalize historical information. So basically we are recognizing images, text, plot to extract this information. So one of the things is trying to understand that's a letter, that's a plot, that's an image, and then other levels of artificial intelligence that help us to make meaning of all this information. Where are the description of a borehole log? Where are the geotechnical conditions? Is that a laboratory test, an in situ test? So basically, we are adding different layers of artificial intelligence with the idea that at some point Darwin will read all the reports for you. It will give you some recommendations, not only in terms of geotechnical parameters, but also giving you this preliminary 3D ground model. So yes, we are using a lot of artificial intelligence. I don't know if Ignacy, if you have more vision on that, because he's the responsible of all the product development, and I know by fact that they are really using artificial intelligence in other different areas.
Yeah, no, we know that there's a lot of hype these days with language models. The artificial intelligence, as Christian mentioned, the artificial intelligence we used in our core technology was more related to machine learning algorithms. We also use in digitalization computer vision, AI-based computer vision algorithms. But in terms of language models, we use those in different parts of our software. One of them is to assign material type, the material type or the material from a layer description. That's an example. Another example is we've trained an algorithm that from tunnel shift report can understand what were the stop reason and is able to classify based on a standardized stop reason chart what was the stop reason related to, and then all this data then we feed to another software piece that's called the historic TBM data repository, where we classify all the stop reason in a standard format, and that the contractor we're working with can use this information in tender phase for future TBM projects.
Okay, so the next question is, what is your opinion on the monitoring tools for slope stability, and what do you think about the future of the business in this sector?
So here the thing, and that's something that we have been discussing multiple times. Right now, at the moment, monitoring data, it seems that it's becoming a commodity. There is data everywhere, but I think that the next step is adding a layer of analytics. We need to proactively analyze this data to actually impact our projects. If we translate that to slope stabilities, traditionally we have been installing sensors in slopes, inclinometers, extensometers, points where we are measuring three-dimensional displacements and even water pressure if water is an issue there. The thing is, we have data, we are comparing this data if we are lucky enough with some kind of thresholds, and then if something surpasses those thresholds, we start thinking about what to do. Then what to do, it's mainly for slope stability, as Ignacy said before, working with limit equilibrium methods, which are good to evaluate stability, but it's not helping you to really understand what can happen before the stability appears. So for us, monitoring data, it's one part of the puzzle to really analyze slope stability. We envision monitoring data in combination with numerical modeling, where you can actually track the performance of your slope before having the instability. So that's the key, this layer of analysis, and that's in some way doing back analysis, but also it's connecting. You don't need to calculate sometimes, but you need to connect the real response from the sensors with what you were predicting and understand the limitation of your models as well as the limitations and the quality of the data. But one of the key points is having a place, a common place where you have data, you have calculation tools, you have some parts where you can keep track what is happening, what we are doing that day in the site. So that's our vision. It's having this digital space where all the geotechnical information is connected and can be visualized. And that's how we envision the future for slope stabilities, but for all geotechnical work.
Okay, thank you, Christian. So the next question is, what type of soil and structural parameters are being calibrated during the back analysis of Darwin?
So basically, right now we are just adjusting parameters. We are adjusting geotechnical parameters from all the different constitutive models that are implemented in Darwin, in Plaxis, but also we can calibrate and play with all the structural parameters that are included in the different type of structural elements in Plaxis, like plate elements, embedded beams, or anchors, as well as some internal iterative parameters that Plaxis is using to convert. So there are multiple options, but are only parameters. What we expect to do at some point in the future, it's also giving the user the opportunity to calibrate geometry, to calibrate the position of the phreatic level, or to actually calibrate the thickness of a specific geotechnical layer. But mainly in Darwin right now, you can calibrate structural and geotechnical parameters.
Okay, thank you, Christian. So the next question is, how is data imported into the system, and what structure does it have to be? If this will be there a live connection with the TBM data?
Yeah, I think this is a good question to wrap up our webinar, because TBM is one of our last developments. So and we can answer this in terms of data, but then maybe Christian can comment what's the vision with our TVM software, and what are next steps and implementations with the software. This is simple. Well, it's simple, but it's very complex because a TVM generates an enormous amount of data, and the frequency of readings it's around like five seconds. Usually what we do is the PLCs from the TVM usually go to a server that's on site, and then all this data is structured. This is structured in relational databases like SQL databases, and usually two things can happen. It's one, all this data locally goes to a cloud database, and that cloud database is mirrored or synchronized to a mirror database, and usually the one from the machine, it's only writing permission. The only one has read permission, and the suppliers connect to that database. In here we have real-time data, and we have a delay of a few seconds. And then another option is that the data from the PLCs comes from a data stream, and then we connect to this data stream and we create this mirror. There's less delay, but yes, in Darwin you can see TVM data in real time with delay of a few seconds. So this in terms of data, then
yeah, for us the vision why we are doing that for tunnel boring machine is because we see a tunnel boring machine as being a big horizontal borehole that can give us a lot of information regarding the ground that we are actually excavating. So the idea is analyzing the response of the tunnel boring machine, we can get some insights to understand what are the ground conditions. And by knowing that, the software can give recommendations in terms of how fast you can go, what is the impact of going so fast in terms of the cutters, when you will need to change the cutters or whatever. So basically, we envision this autonomous tunnel boring machine. What we would like is to learn from those good pilots that are driving the machines and make sure that those with less experience can learn faster from the good ones to make the performance of the tunnel boring machine independent to the person. But don't misunderstand my words. We don't expect to eliminate engineers on the site. What we are trying to do is provide those tools to make the job of the engineers easier and to make sure that they can deliver a better designing, a better management. So to make sure that we can proactively analyze this information to impact in a positive way our projects. At the end, the reality is construction industry, it's responsible for more than 10% the global CO2 emissions. And I think that we have a responsibility as an industry, but also as individuals, to try to change that. And one of the ways to do that is being involved in this digital transformation that the construction industry and the mining industry is experiencing. So that's what we want. It's to be part of this transformation. We don't want to be observers. We want to be part of this transformation. So that's our vision, to create this ground digital space where you can analyze and see what you will be encountering during your projects.
Okay, so we are almost finished the time to the webinar. I don't know if someone of you would like to leave the last questions. If not, I'm going to leave my email in order to contact direct to us, okay, in order to answer the questions. I don't know if you would like to add anything more, any else, Christian and Ignacy?
No, we really appreciate all your questions. That were all of them really exciting, and we're very thankful for your attendance.
Yeah, the same. Thanks to all of you guys for your question, and also apologies to those questions that we couldn't answer because of the time constraints. But of course, we are learning a lot from all those questions, insights, and and things listening from you guys. So thank you very much, and hopefully you enjoyed this webinar that we prepared for all of you.
Thank you so much, Ignacio and Christian, for your time. And thank you to the rest of the system in order to participate in our webinar. Thank you so much. Keep on touch. Bye bye. Nice day.